This video demonstrates the use of a sensor planning service to task a satellite and obtain fresh and rectified imagery. The service was developed by SpotImage and actually connects to the internal satellite tasking system. The client is based on the Spacetime Toolkit developed by the University of Alabama in Huntsville, which provides visualization capability for sensor and GIS data. We first zoom on the area of interest situated in South Africa, where we want to assess the extent of wildfires damage. We then connect to SpotImage Sensor Planning Service to realize a feasibility study of an image acquisition in this region. We retrieve the capabilities of the server and select a sensor that represents all 3 satellites in the SPOT constellation for a better chance of success. A new item for this study is added in the scene tree. When I activate this item, a request is made to the server to retrieve the tasking parameters that the user must provide to realize the study. A form can then be generated automatically on the client side so that the user can provide values for these parameters. This auto-descriptive mechanism is very important since it allows the service to advertise the parameters that are needed. A generic client can thus connect to any SPS without a priori knowledge of the service. We finally choose a region of interest for this study by selecting a polygon on the map. A request is now sent to the server using these parameter values, and the server sends us back the estimated acquisitions needed to cover the area of interest. Since the area is large and needs to be acquired in several passes, it is divided in what are called scenes. Each scene can be visualized on the map, and more information is also available in the right panel. This includes the platform and instrument that would be used, the acquisition mode of the instrument and the resulting ground resolution, as well as the estimated acquisition date and success rate. Now, if the user is satisfied by the results, he can submit the task to the system using the same set of parameters previously entered. Once the task is started, the sensor planning service can also provide status about the advancement of the task. The user can either pull for the status or be notified automatically when a certain event occurs. The report contains information about the actual characteristics of the image, such as the platform and the instrument used, the acquisition time, the resolution, cloud cover, and incidence angle. A preview is also available and can be roughly geolocated within the scene footprint. Since the process has been accelerated for this demonstration, we'll see that a second scene has been acquired if we refresh the status. The service also gives us information on where to get the full resolution unrectified imagery that has been acquired and produced. In this case, the client can retrieve the imagery via a standard OGC web coverage service interface in either GeoTIFF or JPEG 2000 format, as well as through a streaming JPIP server.